Okay, so let's check some problems that about the divider is of this formula AK. This is power form. So typical example just like that. How many zeros? How many zeros at the end of this product? So such a problem is just like that. What is largest k such that 10k is the fact of a? Okay, like let's say for this number like 1 2 3 so 0 0, if we have 4 0 or 1 or 3 0 0 0, we have 4 0 at the end, then this number, this means this number we have 10 3 or 10 4 can be a fact for this number, right? Okay, so for this number we find, so 10k equal 10 equal 2 times 5, so 10k equal 2k times 5k. So we just check the exponent about 2 and 5. Okay, so for this one, 25 to square 2 of 5 2 5 2. Okay, so this equal 5 14th power, right? And this 8 is 2 3, so 2 3 2 3 3 3 is 2 9th power. Okay, so from here we can find this number should be, we have this fact 10 9, right, as a fact. So how many zeros? We have 9 zeros. Okay, so let's check this problem, same problem. How many zeros? So should it be more precise? How many zeros for non-de factorial? So non-de factorial is non-de factorial is just 1 times 2 times 3 times 4 times 5 times so time 89 and 90, right? So this is non-de factorial. So factorial is just multiply those numbers starting from 1 until that number. So we want to find how many zeros. So here, how many zeros means at the end, right? Yeah, we're talking about here, actually more precise, should be at the end of this number. So we're just talking about like what is the largest k, that 10k is a fact of non-de factorial. We want to find the largest k. So again, so 10k equal 2k 5k. So 2k is the number from even numbers, like 2, 4, 6, we have 2 some power. 5, this is 5k that come from those numbers, like 5, 10, 15, like those. So we know the even numbers or multiple of 2, those numbers is much more than the number of multiple of 5. So here, so we just let's check this. We can forget this 2k. We just forget, just check 5. We want to find 5k largest k such that 5k is the factor of 90. So we just list those numbers for so 5. So for those numbers, so we have 5 and 10 and 90. So those number we just take 1 5 out. 1 5 out. So this equal 5. So time 1 2 3 like that, and then multiply 18, right? Okay, so each one we have 5 1. So we say this k can be 18. But for those numbers, we still have multiple of 5. We have those can be, we still have 5, 10, and 15. So from here, we still can take 1 5. So we should plus 3, right? So we say we there should have 21 zeros at the end of non-day factorial. Okay. Okay, so this problem is quite the same. Like we want to find the largest power of k2 as the divisor of 20 factorial. Like we want to find the 2k that is a divisor or factor of 20 factorial. So the idea is the same. We just check so check 2k. So we have like from 1 to 20 we have 2 4 6 8 and 20. So we take 1 to outside, so this equal 1 2 3 10, right? So for each number, from each number we take 2. So this k we can take 10, right? We have 10 of them. So plus, so from 1 to 3 to 10, we can take 5 of those. Like we can take like 2 4 6 8 10, right? So each one we take 2. So that become 1 2 3 4 5, right? So we have 5. Okay, then for this we also can take 2. So we can take this 2 to 1 and this 4. So this 4 is 2 square, so we can take 3 more 2. So totally we can say this equal 18. Okay. Okay, so for this problem, we want to find the largest part of 2, like 2k is a fact of this number. So say 13.4 minus 11.4. So this number we can find this number. So we continue this as product form. So this a square minus b square, so equal a square. So a minus b, a plus b. Okay. So for this one, this square minus, so we still use a square minus b squared. So this equal 2 a minus b, 2 multiply a plus b, 24. And this number even, odd plus odd even. So so here we also have a 2 because it's an even number. But for this number, we also can find exact value. So let's check exact value. So 13 square 169, 11 square 121. So add them up is 290. Okay, right? Okay, so we can change the 2. So 24 can be 3 times 8. 2 3, and 290 can be changed to 2 times 145. Okay, so we can see this k equal 1 plus 3 plus 1, so 5. Okay. Okay. So for this problem, also quite the same. We want to find the largest n, so that 5n is a factor of this number. So for this number, so we know 99's factorial is equal 98's factorial multiply 99, and 100 factorial equal 98 factorial, then multiply 99 and multiply 100, right? So we can take, so this equal 98 factorial. So multiply, so here we take 98 factorial out, the 1 plus 99 plus 99 multiply 100. Okay. So this is 100. Okay, so this is 100. So we find this take 100 outside. So this equal 100 multiply 100. Okay. Okay. So for 100 we have 5, 2, right? So here also 5, 2. So we can have 5, 4. So let's check. Let's focus on this. So how many 5 as a factor for non-8 factorial? So we use same way. Like we take those number. We have 5 and 10 and 15, like those, right? And last number 95, right? So those numbers we can take one factor of 5. So this number we can write this as 5. So that's 1, 2, 3, and the last one is 19, right? Okay, so for this k, for this n, I'm sorry. At the first we can see this n equal 4 plus we have 19 of, okay. And then for those number we still can check we still have some factor of 5. So we have, let's say, so here we have 5, 10, 15, right? Yeah, among this. So from here we also can take 3. Okay, so the answer is, let's say, 26. So we have the largest n is 26. Okay. Now let's check some other problems. Okay. So for this problem, it says we have a 5-digit number. So those 5-digit numbers come made from those 5 digits. So let's say could it be like 5, 1, 4, 2, 3, like those numbers. So we have many of those numbers. So we want to find such a number that satisfies these conditions. This is first 3 digits, the PQR is divisible by 4. So divisible by 4, this condition is a little bit tough to handle. So let's check. So let's forget that. Let's check the so second. So the 3 digits, the QRA is divisible by 5. So from here, we can get this. This ace should be 5, right? So we know this 3. This number is divisible by 5. So last digit should be 5 or 0. So here no 0. So this number should be 5. Yeah. Okay. So then let's check this. This R is T. This 3 number. 3 digit number is divisible by 3. So divisible by 3 means R plus S plus T. Let's say R is R plus S. Oh, S we already know is 5, right? So R plus S plus T is those number could be 3, 6, 9, 12, or 15. But we find, oh, this cannot be 15, and cannot be 3, and it cannot be 6. Because if there's 6, R and T, so one of them should be 0. So only case is R plus the 5 plus T equal 9 or 12. So let's check. There's 2 possibilities. So let's say, so if this equal 9, so this means that if R plus T equal 4, so then RT we have only two possibilities, 2 solutions. Could it be 1 4? 1 3. I'm sorry, 1 3 or 3 1. Right? Okay. So let's check both of them. So if those conditions, if this is 1 3, so R is 1, T equals 3, so we have this number P Q we don't know, but R is 1 and S is 5 and T equals 3. Okay, so this number, so PQ, so actually the PQ can be only 2 4. So this number could be like 2 4 5 1 5 3 or 4 2 1 5 3. So if this RT equals 3 1, so this we say this number PQ PQR is 3 5 1. So could be this, right? Could it be like 2 4 3 5 1 or 4 2 1 5 3. So we just check which number can satisfy this. PQR is divisible by 4. PQR this. So this divided by 4 or cannot be divisible by 4. This one not work. This one not work. This not work. This not work. So this means this R plus T equal 4 not work. Okay. Then so we have to check this case. If R plus T equal, so R plus T plus S R plus 5 plus T equal 12. So this means R plus T equals 7, right? So if this equals 7. So then RT can be only also 2 cases, right? RT can be 3, 4, or 4, 3. So we can, so this number like P, Q, R, S, T can be those numbers. Let's say P, Q we still don't know. P, Q, R, R3, S5, T4, or so here we have or let's say P, Q, R is 4, 5, 3, right? So PQ, what is PQ? So PQ can be 1, 2, or 2, 1. So here we have two numbers. It could be 1, 2, 3, 5, 4, or 2, 1, 3, 5, 4, or this one it could be like 1, 2, 4, 5, 3, and 2, 1, 4, 5, 3. So we just check which number satisfies this condition. PQR is divisible by 4. So we find only this is divisible by 4. So only this number. So PQR. So we find PQR only this number. Is this number should equal this number 1, 2, 4, 5, 3. Okay. So what is the question? Question is what is P? Is P equal 1? Okay. So this problem says which one cannot be a sum of 4 consecutive odd numbers. So here we have those were consecutive and odd. So the consecutive odd number just like that 1, then 3, 5, 7. So those are 4 consecutive odd numbers. Or so let's say we pick some others. Let's say suppose here's 7, then 9, then 11, then 13, right? So those are consecutive odd numbers. Okay, so we find that if we have those two, so this is this minus 2, so this is plus 2. Okay, and so for those odd number, we can assume that 2k minus 1, 2k plus 1. So if we have the two consecutive odd numbers, so usually we can write them as 2k minus 1, 2k plus 1. Okay, so then here is 2k minus 3, right? Minus 2. Now from this number minus 2, then here from this number plus 2, so 2k plus 3. So if we add them up, so this plus this plus this number plus this number, so we find this equal 8k. So a sum of 4 consecutive odd numbers should be a multiple of 8. So we just check which one cannot be a multiple of 8. So we say this, right? 100 is not a multiple of 8, or 8, this number is is 100 is not divisible by 8. Okay, so for this number, this is there are 24 such numbers, 24 4-digit whole number that use each of these 4 digits. From these 4 digits, we can make some number, 4-digit number, that could be 2, 4, 5, 7, right? Or could be like a 2, we just changing the position, 5, 7, 4, like that. So totally we have 24 of them. So how can we get this 24? So this 24 actually is 4 factorial. So factorial come from this way. Like we have this 4 position, and the first number we can put each of them. Can be 4, can be 2, can be 4, can be 5, can be 7. So here we have 4 ways to put the first position. And for second one, so by now we have 3 number left. So could put any one of them to here. So we have 3 ways. So same way. So here we have 2 ways, and here we have 1 way left. So multiply together is 24. Okay. So this question says, among these 24 numbers, we have one such number is a multiple of another. One is a multiple of another. So we don't know which one. So here the question, we want to find that one. Okay, so looks like that. We have like a 7, like a, let's say, let's say 7, 2, 4, 5. This number equal multiple of this number. Okay. So we can guess this number, the multiple cannot be 1, cannot be, so this cannot be 2, like most likely can be 3. Cannot be 1, cannot be 2. If this is 7, 2, 4, 5, if they multiply 2, this become even, right? So let's say if this is 5, so here should be 5. Yeah, and I think first number should be 2. Okay. So let's say 2, 5, and 2, 5. So let's check how about 4, 7. Okay, so let's say 2, 4, 7, 5 multiply 3 equal yeah. Let's say. Oh, we find this, yeah. Okay, so we know this number 7, 4, 2, 5 equals 3 times 2, 4, 7, 5. Okay, so this number should be this, yeah. Okay, so we say this number. So such a problem is just check our observation. We just try this, try that. No formula, right? No need, actually no need for math skill. Just try, check this, check that. Okay, so for this one we have 3 numbers, so we want to find which one is largest, or we want to make a ordering of those numbers. So we have 10, 8, and 5, 12, and 2, 24. So we just need to compare. So let's say we compare 2 of them. So let's compare this. So this equal 5, 12. Oh, we just change the 224 as 4, 12, right? Okay, so we know this 5 to, so at first we say 512 is larger than 20 to 24. Okay, so then compare this. How about a 10, 8, 5, 12? 10, 8, 5, 12. So we just change the 10, 8, 10 as 2 times 5. So this equal 2, 8, 5, 8, 5. So we compare 5, 12. We cancel 5, 8. So it become 5, 4, right? So we just check, let's say like 2, 8, and 5, 4. Which one is big? So we just change 2, 8 as 4, 4, and 5, 4. So we know 5, 4 larger than 4, 4. So we say this larger than this. Okay, so now our conclusion is 5, 12 is 5, 12 is larger than those numbers. 5, 12 larger than 224, also larger than 10, 8. So then we need to compare these two numbers. Let's say 224 and 10, 8. Which number is big? Okay, so again, like here, so we change this 10, 8 as 2, 8, 5, 8. So cancel this 2, 8, 5, 8. So this will compare to 16, right? So 2, 16, 5, 8. Which one is big? So again, so we can say 5, 8. So we just change this 2, 16 as 4, 8. So we know 5, 8 larger than 4, 8. So we say 10, 8 larger than 224. Okay, so we know those three numbers should be like a 5, or smallest one is 224, then 10, 8, then 5, 12. Okay, so we can stop here. Okay.